Many years ago, a brilliant young professor from Caltech, Dr. John DeBeery, discovered that when schools of fish swam together, they created coupled vortices with their movements of their tails. And this created an increased efficiency for the entire school of fish. And he wondered if this might be applicable to wind turbines. So he looked it up and found out that Wind Harvest had a patent on the coupled vortex effect. He met with Bob Thomas, looked at our 3-turbine array in Palm Springs, was quite impressed, but decided that those turbines were too large for him to be able to do the kinds of field studies he wanted to do to see how H-type turbines, like wind harvesters, would affect the flow of wind through a wind farm. So he used another turbine called the Windspire, a small little 1 and 2 kilowatt turbine, set up an experiment in the Antelope Valley near Southern California with 20 or so of those turbines, and collected an immense amount of data and moved these turbines through all kinds of different positioning, and found that when they are placed close together and they counter rotate, the shed vortices that come off the back of their blades draw down faster moving wind from up above the turbines down into the array of other turbines. This was an impressive discovery. It showed that if you added these vertical axis wind turbines in wind farms, we should see an increase in energy output. It went on to do many, many different studies on this effect, from Cambridge University to Stanford University to Columbia University in Canada, and much research went into looking into this phenomenon. And the fundamental summary is that they believe that if a field of vertical axis wind turbines is properly placed into a wind farm, that wind farm horizontal axis turbines, the existing turbines, should realize a 10% increase in energy output. That's a nice sweetener to being able to make double use of the land and the roads and the zoning with an understory of vertical axis wind turbines.